is Connor Nason, and I'm going to be discussing the phases of an action potential and the events that occur at each segment of the neuron. So I'm going to first start with the resting membrane potential, and this is approximately negative 70 millivolts. This is influenced by potassium leak channels and sodium leak channels, and this is influencing while the neuron is at rest. Uh, Moving on, we come upon the receptive segment. This is typically where your dendrites are located, and in the receptive segment, you have gridded potentials, and these are like uh, tiny, short-lived changes in the resting membrane potential. Uh, in a postsynaptic neuron, these gridded potentials are known as postsynaptic potentials, and they can cause depolarization or even hyperpolarization. So, if it causes depolarization, the postsynaptic potential is an excitatory postsynaptic potential. And if it causes repolarization or hyperpolarization, it is known as an inhibitory postsynaptic potential. Um, so in hyperpolarization, this is where the potassium ions are exiting, where they are exiting and chloride ions are entering. And for depolarization, this is where sodium is diffusing into the cell. Um, Moving towards the initial segment, this is where the summation of uh, inhibitory postsynaptic potentials and the excitatory postsynaptic potentials occurs. And this summation has to reach, well, not has to, it can reach threshold memory potential, and this is at negative 55 millivolts. Um, Sometimes the sum may reach, and whenever that happens, an action potential will be generated. So based on the all or none law of the whenever the threshold is reached, the voltage gated channels will open, and the action potential is produced and propagated down the axon. So then, if the threshold is not reached, the voltage gated channels stay closed, and then no action potential will be produced. So if you're going to dress up for Halloween and you happen to be Yoda, one of his quotes that I think could help you with this, remembering this, is "Do or do not. There is no try," because uh, if the threshold is not reached, no action potential is going to be made. And so I made this drawing of Yoda, and he said, I have them written down. It's kind of backwards. Reach or do not reach, there is no between. So I thought that was kind of funny. Um, Next is the conductive segment, and this is where the axon will conduct action potentials. Uh, the action potential will involve depolarization, which is where sodium will diffuse into the cell, into the neuron. My bad. Um, and then it also involves repolarization, which is where potassium will exit out of the exit out through the voltage gated potassium channels. So then I drew the steps. They're kind of backwards though, because I'm using the camera. Um, First step being where the threshold is reached. Uh, Sodium is going to come to the voltage gated sodium channel that is open. And then next is depolarization, which is where sodium is going to be going in. And then next is repolarization. So this helps us return to our resting membrane potential. And this is where potassium is exiting out. And then next is hyperpolarization, which happens because the voltage-gated potassium channel takes a bit longer to close, and then we have where we return to resting membrane potential because of the leak channels. So there is a period of time after an action potential is propagated, and it's called the absolute refractory period. And in this period, uh, no no stimulus can cause an action potential to be produced. Now, after that, there's a relative refractory period. So in that, this is where an action potential can be produced, but the stimulus strength has to be greater than what it was before. Then there's the two types of conduction. First one being continuous conduction, and this is where the uh, action potential is propagated through the unmyelinated axons. And next is saltatory conduction. This occurs in myelinated axons, and this is where the action potential will travel from node to node. This is known to be faster than continuous conduction. Next segment is the transmissive segment, and this involves the activity at the synaptic knob. So the action potential arrives and causes voltage-gated calcium channels to open, and then calcium will diffuse into the knob and then start binding to proteins that are associated with the vesicles that are in there, and this triggers exocytosis. And then this allows for the synaptic knob to release neurotransmitters after vesicles have fused with the membrane. Now, one of the main neurotransmitters that are released is acetylcholine, and this is a category of its own. This also provides one of its functions is to provide you with voluntary muscle movement and allows it to be enabled. For a nervous system disorder, I guess could be Parkinson's, and this is where an individual's movement is affected. And some symptoms of this is an individual having tremors or stiffness, and their movements become slower.